Okay, today we're going to be graphing linear inequalities. Remember, you have to get it in the slope-intercept form, which is y equals mx plus b. Remember, to do that, to solve for y, you have to move x and then divide, divide, divide. That was the way to get it into the form y equals mx plus b. M is your slope, rise over run, and b is your y-intercept. Okay, so here we go. Remember, when you're talking about inequalities, you're talking about less than, that's less than, and greater than. Less than's your left hand, greater than is your right hand. Less than is without a line underneath it, is a dotted line, and you shade below. And you might remember that, look, less than is low. Okay, same thing with less than or equal to, except that it's a solid line, shade below. Okay, if it's a greater than without the line, it's dotted. Okay, and you shade above. Okay, if it's greater than or equal to, solid line, shade above. So these two here, greater is above. Okay, less than is below. All right, so we're going to sketch this. So we've got y equals mx plus b. Okay, so your m is a negative 2 over 1. Remember, that's rise over run. Okay, and it's going to be in a negative slope. So your line should look like that, going in a downward motion, starting high, going low. Then your y-intercept is a 6, which means the very first point, the beginning point that you're going to graph is 0, 6. Okay, so we come over here. Remember, this is my y-axis. This is my x-axis. We're going to go up 6. 1, 2, 3, 4, 5, 6 right here. Your y-intercept should always end up on your y-axis. Okay, we're going to use the slope. And we're going to make sure it's a negative slope. So you're going to go down 2 over 1 to the right. Down 2 over 1. Keep on going. Down 2 over 1. Down 2 over 1. Keep on going all the way across. Okay, the very first line that we're going to do here, we're just, oops, I went up 1, 2 over 1. Sorry about that. That's not right. Up 2 over 1. Okay, now, what type of line type? Okay, well, when you're doing the line type, you've got to look at the inequality. It was a greater. Okay, no line, so it's not a greater than or equal to, so this is a dashed line. Dashed or dotted, some people call it dotted. Okay, so this is pretty much dotted, so I'm just going to add a couple of more dashes in between because I made that little boo-boo right there. Keep on going. Okay, make sure there's arrows on the end of your line because it is a line. All right, then you have to figure out shading. So inequalities have two more parts. They've got a line type and they've got a shading. Since it's greater, this is above the line. So how do you figure that out? Well, lay your pen or pencil down on your line, and above the line over in this area this way should be shaded. Okay, the reason we shade is because that tells us where our solution set is. Solution set, because inequalities is not just one answer. It's not one point of intersection when we do two lines. It's the shaded area. Okay, so all points in this area right here are solutions to this inequality. Okay, let's move on down to number 2. Okay, number 2 is not yet in the y equals mx plus b format because we've got a negative 3 here. So I'm going to go ahead. I don't have to move the number over because it's already over, and I don't have an x. No x variable. So in this one right here, when you don't have an x variable, your line is going to be horizontal. Okay, that goes across like that. All right, but I'm going to go ahead and divide by -3 just to get my y by itself. Whenever you divide by a negative, you got to ding, 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 flip that thing. Okay, so I've got y. -6 divided by -3 is a +2. So anytime you divide or multiply by a negative, divide or multiply by a negative number, you must flip the inequality. And we learned that when we were doing linear inequalities. Okay, so since this was greater than or equal to, now it is less than or equal to because I divided by a -3. All right, so my m is 0. There's, for a horizontal line, the slope is always 0. My y-intercept, or my b, is a +2. So I'm going to graph the point 0, 2. Here's my y. Come up here, right here, all along that line, right here, all along this line, going horizontal, is my line. Okay? Now, since we're looking at line type, we have to look at the inequality. Since it had a line right there, it's solid. If it's less than or equal to or greater than or equal to, it's a solid line. That means every point on the line is part of your inequality. Okay, it's part of your solution. Okay, shading. Okay, on this one right here, since it's less than, we're going to shade below the line. Below is less than. So that means all the points that are below my y equal 2 line are part of your solution. Okay, let's look at number 3. Number 3, what we're doing is, you notice there's no y variable. Okay, this is a vertical line. Okay, that's when you have an x and no y. Goes like that. Okay, this is the only line that's not a function. Okay, so if I come over here and look, the slope for a vertical line is undefined or no slope. Okay, so I'm going to come over here at -3. When x is -3, 1, 2, 3, it's right here. The line is going up and down, our vertical line, so it's going to go like that at x is equal to -3, because all along that line, x's are -3. Okay, since I'm looking at the line type, and the line, our inequality had a line underneath it, so that means it's going to be a solid line. So I'm going to go ahead, draw a line straight up and down, not too straight, but that's okay, with a solid line. Shading. Okay, when you have a vertical line, you can't shade above or below. So less than and less than or equal to is going to be to the left. Greater than or greater than or equal to is to the right. So on these, you can't shade above or below, so they're going to be left or right. Less thans are left. Greater thans are right. So this here is a greater than or equal to, so we're going to shade to the right. So all points to the right, and including this line, are part of your solution. This right here is your solution set, the shaded area. Okay, if the line is solid, the line, all the points on the line are part of your solution. If the line is dashed, the points on the line are not part of your solution.